everyone, this is a video on 2.1 number 11 through number 13. So let me look at this. So it looks like number 11 and 12 also actually have to do with applying some of our rules in a more general sense. So instead of actually giving you an equation for function f and function g, I'm just saying in general, if a function looked like, so for example this first one, 3 times one function minus 4 times another function, how would we find its derivative? So I would say you should start with just a general formula. So the derivative of h prime, we're going to use first sum and difference rule. This is a difference of two functions, so we can look at them one at a time. For the first piece, we're going to next use constant multiple rule and say, okay, if there's a 3 out in front of our function, it's just going to stay there, and we'll multiply it by the derivative of our function, which is just going to be an f prime. And then when we move to term number 2, we've got the same rule. 4 is just going to hang out in front, and it's going to get multiplied by the derivative of our function. When we plug in, where are we supposed to plug in? Oh, I skipped a step. Well, we'll do h prime of 2. I can go back and do h of 2 as well. When we plug in 2 to our derivative, we need 3 times f prime of 2 minus 4 times g prime of 2. 3 times, there it is. Okay, so f prime of 2, looking up here at the top, is negative 1/2. And minus 4 times g prime of 2, which is 2. So I'm seeing that I'm writing too big. Negative 3/2 minus 8. 16, which is negative 19 over 2, assuming I didn't do silly arithmetic. Okay, let's switch colors. For h of 2, the part that I skipped, we can just use the formula. We need 3 times f of 2 minus 4 times g of 2. F of 2 was given as 5, so we need 3 times 5. Oops, I'm thinking 15 and I started writing it. Minus 4 times g of 2, which is negative 3. So I see 15 plus 12. 27. Okay, for part B, we want the equation to the tangent line at the point 2h of 2. Okay, so to find the equation for a tangent line, we need the slope, and the slope comes from the derivative. So we need the derivative evaluated at 2, which we just did, and it's negative 19 over 2. And then we also need a point. And we did that as well. That was the h of 2 part, so we know it goes through 227. And then we could just use point slope form. Y minus 27 equals m times x minus 2, which means y equals negative 19 over 2x plus 19 plus 27, which is negative 19 over 2x, 3747 plus 46. Again, assuming I didn't do any bad arithmetic. Okay, and then last part of this one is p is the function defined by the rule p equals negative 2f plus 1/2 g. Is p increasing, decreasing, or neither at a equals 2? And this is interchangeable. You could just say x equals 2 there. Some calc books really like using a different letter for their specific x value, but it's kind of silly, so I think I've just carried it through and not changed it, but I don't love it. So I would start with p prime, here, I'm going to zoom a little, of x. So first find the formula. So it's going to be very similar, negative 2f prime of x plus 1/2 g prime of x. And then when we plug in 2, oh, and maybe I should explain my thinking there. If we want to know if it's increasing, decreasing, or neither, we need to know if the derivative is positive, negative, or 0. So that's what I'm working on right now. Okay, so when we plug in 2, f prime of 2 is negative 1/2. G prime of 2 is 2. Ooh, okay, so we get positive 1 plus 1 is 2. And because that is positive, the function is increasing. So again, always connecting back to that idea that derivative means slope of tangent line. The slope is positive, the function is increasing. Okay, so there's number 11. For number 12, I think it's similar, but we have graphs to get the information from instead of just being given a select few pieces of information. So first question, when is P not differentiable? So both of these functions are made up of straight line segments, which we're going to have no problem finding the derivative of a straight line segment. So the only thing we're worried about is these corners. So it looks like P is the blue function, so P is discontinuous at negative 1 and 1. Well, it's the same values for both, I guess. And Q is also not differentiable at negative 1 and 1. And then part B asks, if we make up a new function that's P of x plus 2 times Q of x, when is that one not differentiable? And the answer is at the exact same points. So this kind of comes down to the next part. So let me just write that down and then I'll refer back to it a little bit. If we wanted to find the derivative of r, it's going to be the derivative of P plus 2 times the derivative of Q. So as long as P and Q are differentiable, R should be as well. The only time we're going to have trouble with R is if we get nonsense out of P or Q, and that's why it's going to be those same 2 points. Okay, so for R prime of negative 2, we're going to have to refer back to our graph and say, okay, P, again, is the blue one. So at negative 2, we're looking at this point right here, and since it's a prime, we're looking for slope. And I see if we go down 1, we go over 1/2. So the slope is going to be negative 2. You could also go down 2 over 1 if you like that better. And then we're going to get 2 times Q prime of x. Okay, so Q prime of x, Q is the green one. So we're looking at, what are we looking at this point? Kind of the same idea. If we go over 1/2, we need to go up 1.5. So this is 3/2 over 1/2. And that's going to give us a slope of 3. So 6 minus 2, it looks like R prime of 2 is 4. And it's going to be really similar for R prime of 0. Except we're going to get off a little easy on Q. So let's see, I'm going to switch colors here. Okay, so now we're interested in this point and this point. So blue graph is P prime of 0. We are going, we can look at the whole line segment even. If we go over 2, we go up 1. So rise is 1, run is 2. That means our slope is 1/2. And then G prime is 0, so that actually makes that part really easy. We're looking at this top point right here, and the slope is definitely 0. So we get positive 1/2. Okay, and then 13, let's see, 13 is similar to 12. Okay, so we're going to want some formulas. I'm just going to jot them down up at the top. Oops, erasing what I write. H prime of x is going to be 3G prime of x minus F prime of x, and then J prime of x is going to be 4F prime of x. Oops, let me copy that down. And then this important thing to think about is that that's the same as 1/2 G of x. Sometimes people try to make that really complicated, and it's not. So the 1/2 will just stick around, and we'll get a G prime of x. And then we're interested in what's happening at 1 and at 2. So let's look first at x equals 1. And I can see that f of 1 is negative 2. That's the y value. And f prime of 1 looks like it should be 0. If I was going to draw a tangent line there, it would be horizontal. G of 1, this is the y value, is 1. g prime of 1. Let me try and draw my 1 work. That looks pretty good for a tangent line, so it looks like a slope of -1 is in the ballpark. Again, you have a little room, but if you draw your line and it crosses the graph of g a couple times close together, that's a bad sign. Tangent line should just touch, so sometimes it does cross off in the distance somewhere, but it shouldn't cross through multiple times right near your point. Okay, so let's do the first one, and then we can look at what's happening at x equals 2. In fact, we can do the first two. So we said h prime of 1 is going to be 3 times g prime of 1. So I'm just looking back up at this formula at the top of h prime. So we need 3 times g prime of 1, which we said is -1, minus f prime of 1, which we said is 0. So it looks like we're getting -3. Oh, I did all this stuff to find f of 1 and g of 1, and I don't think we even need them, but we'll see. Okay, j prime of 1. Again, looking back up at the formula, we're going to have 4 times f prime of 1, which is 0, plus 1/2 of g prime of 1, which is -1, so it looks like we're getting -1/2. And then, here, I'll switch colors for this. At x equals 2, okay, I'll just look at the primes this time. Let's see, maybe a slope of 2. That looks pretty decent. It looks like f prime of 2 is about 2, and I think g can't be, I think it's got to be a little steeper. So notice, if I draw a slope of 2, the way it doesn't really follow the curve, that's not steep enough. That's definitely making a secant line. Whereas if I make it a little steeper, this one has a slope of 3, -3, that looks a little bit better. So g prime of 2 is about -3. Okay, so down here, again, we go back to using those same formulas. H is 3 times g prime, which I said is -3, and then it's minus f prime, which I just said is 2. Okay, so I get -9 minus 2, -11. And then j prime of 2 is going to be 4 times f prime of 2, which was 2, plus 1/2 g prime of 2, which is -3. So we're getting 8 minus 1.5, so 6.5, 6, 2, 12, 13 halves? 13 halves, I think. Okay, hopefully that's helpful. Let me know if you have more questions. Thanks for watching.